Welcome to the Trig Chapter 2, Section 1 lesson video. We're going to be talking about functions of acute, trig functions of acute angles today, and more importantly, certain specific angles that are really important to us. So let's go ahead and get started. If you don't have your notes out, I would go ahead and take some notes out at this time. I think they'll be very important for today. So we're going to find the 6 trig functions for any acute angle and standard position. We can use the cofunction identity to write a function in terms of its cofunction. We can compare function values of acute angles to determine if a statement is true or false. And then lastly, we're going to be focusing on these 30, 60, and 45 degree angles. Those end up being our most important angles that we use the most often. All right, so given any angle in standard position, we can find the sine, cosine, and tangent, and then reciprocate them to get the cosecant, secant, and cotangent using our normal right triangle trig. Given our x value and our y value, we can find our r value using this formula up here, the square root of x squared plus y squared square rooted. That gives us the length of this hypotenuse. Really, it's just the distance formula. Otherwise, sine will always be the y value over the r value, no matter what quadrant we're in. Cosine will always be our x value over our r value, and tangent will always be our y value over our x value. All right, so one thing we're going to talk about real quick is something called cofunctions. So normally we match up sine with cosecant, tangent with cotangent, and cosine with secant. Now, that's reciprocal. That's matched up based on reciprocal. They also match up with their cos based on something else. So given a right triangle, ABC, where C is the 90-degree angle, we're going to notice something. Let's go ahead and let's fill this in real quick. The sine of angle A. So here's angle A. The sine is A over C. A over C. So I'll go write that in. A over C. Cosine of the other acute angle. So if I come up here, the cosine of this angle is also A over C. So the sine of A is A over C. The cosine of B is also A over C. So sine and cosine, hence the name cofunction, sine, cosine, are both A over C. Now, what do A and B have in common? We'll talk about that in just a second. But think about a triangle. What do the degrees add up to? And if this already takes up 90 degrees, what do A and B have to add up to? All right, so let's keep going. So tangent of A, so if we look at tangent of A, that's A over B. If we look at tangent or cotangent of the other angle, so we did tangent of A, so cotangent of the other angle, that's instead of opposite over adjacent, it's adjacent over opposite, is also A over B. I'm going to make that A look a little bit nicer. And then lastly, we have this secant of A. So secant is cosine's reciprocal. So that is our adjacent, instead of our adjacent over hypotenuse, it's our hypotenuse over adjacent. So that's C over B. And then cosecant is sine's reciprocal. So if we come over to angle B, instead of doing opposite over hypotenuse, we'll do hypotenuse over opposite, which is also C over B. So you're noticing this relationship. If I have a function, sine, and its cofunction, cosine, you hear it, cosine, of the other acute angle, they equal the same thing. Okay? So here's what this is saying. Given a triangle where the triangle's angles add up to 180 degrees, which is all triangles, and angle C is already 90 degrees, then we know that the other two angles, A and B, have to add up to 90 degrees. So what we just saw in that last slide was that if I take the sine of one of those angles, it'll be equal to the cofunction, the cosine of its complement. So in other words, A and B have to add up to 90 degrees. Same thing with tangent. If I take the tangent of an angle, the cofunction, cotangent of its complement, the angle that makes A add up to 90, have to be equal. Lastly, secant goes with cosecant of the angle that would, when we add it with A, adds up to 90. So we'll just make up a couple quick little silly examples. So the sine of 20 degrees has to be equal to the cosine of 20 plus 70 make 90. So notice sine and cosine are equal when the angles add up to 90. We can make up another one. We can say the tangent of 15 degrees is equal to the cotangent of, all right, so 90 minus 15. We can do a little math off to the side real quick if we need to. All right, so that's 75 degrees. And then just finish off the set. Secant of, let's say, 89 degrees is equal to cosecant of, we got to figure out what would make that add up to 90. Well, that takes one more degree. So when these cofunctions are set equal, secant, cosecant, tangent, cotangent, sine, cosine, their angles on the inside have to add to 90. All right. So we can use that for a couple different types of problems. So the first type of problems are similar to what we just did. So we'll figure out what the cofunction is and then figure out what angle will make these add up to 90. And then the second type of problem is we already set the cofunctions equal, sine with cosine, and then we have to take these inside pieces and find what value will make their insides add up to 90. All right, so let's go ahead, let's get started. So cosine's cofunction is sine. And then 90 minus 52, 90 minus 52, that's going to be 38 degrees. So cosine of 52's cofunction is sine of 58 degrees. Notice that's not the reciprocal. Reciprocal is something else. That's how we do our SOHCAHTOA stuff. This is called a cofunction. It's something new. Tangent goes with cotangent. It's the same thing with co in front of it. And so we have 71 degrees, so 90 minus 71 degrees is going to be 19 degrees. And then lastly, we have secant that goes with cosecant. 90 minus 24, that's going to be 66 degrees for its cofunction. So really what we're doing is figuring out which one is the co-version of the original, and then what makes the inside pieces add up to 90. All right, our second type of problem is if I say, hey, these are equal, and you notice that this one's cosine and this one's sine, they are cofunctions, then that means that their insides here, if they are equal, have to add to 90. So what we can do is we can say theta plus 4 plus 3 theta plus 2 equals 90. Now it's really common for people to set the insides equal, to say this equals this. That is not correct. Be very careful that you don't do that. The insides add to equal 90. So 3 theta plus theta is 4 theta plus 6 equals 90. Subtract that 6 over, we get 4 theta equals 84. Divide by 4, you get theta equals 21 degrees. So in order to make this a true statement, make sure that the cofunctions are actually equal. This theta in here would have to be 21 degrees. All right, our second thing we're talking about today is comparing functions of acute angles. And I'm going to fill in a couple things real quick here. So what this says is as theta increases from 0 degrees to 90 degrees. So as we go from 0 degrees to 90 degrees, so if we're on our angle right here, as we go from 0 to 90 degrees, something's going to happen. The values of sine of theta are going to increase. The values of secant are going to increase, and the values of tangent are going to increase. The values of cosine are going to decrease, and then the values of cosecant are going to decrease, and the values of cotangent are going to decrease. Now, the way I like to think about this is I like to think about the sine of 0 is 0, the sine of 90 is 1. So sine increases, cosine decreases, it does the opposite. It starts at 1 and then goes to 0, so it decreases. Tangent also increases. The reciprocals always do the opposite. So if you can remember these first three, then you'll know the reciprocals do the opposite. So what we can use this for is we can use this for comparisons. Now, a lot of times if you have a calculator, you can just plug this in and see it. But if you didn't have a calculator on you and you're trying to figure out which one of these is a bigger value, you know that as tangent, as it goes from 0 degrees to 90 degrees, it increases. So 40 degrees to 80 degrees, the bigger the degree for tangent, the bigger the angle. So we'll go ahead and say the tangent of 88 is over there is going to be bigger than the tangent of 40. Another way we say this, tangent of 40 is less than the tangent of 88. And then sine also increases. So we have 20 and we have 18. So the bigger angle for sine is bigger. So we can say the sine of 20 is greater than the sine of 18. 20 is greater than sine of 18. So we can do this as long as we have the same two trig values. Also, if I gave you a cofunction like we did on that previous slide, you can calculate it by changing it to the cofunction and finding the complement, so subtracting from 90. But then we can compare them and we can see which one is bigger and which one is smaller. All right, so last but not least, we're going to talk about our special right triangles. Now, when we do trig functions, a lot of times we can have all sorts of angles, but we're going to focus in on a couple certain specific angles. And because of that, it's going to make us be able to memorize certain trig values and be able to calculate them really quickly. In order to do that, though, we're going to kind of simplify our special right triangles. Rather than using A's and B's, we're going to use the number 1 for our shortest side. So across from the 45-degree angles here, we're going to say these are 1. And then across from the 30-degree angle, we're going to say this is 1. In our 45, 45, 90 triangle, if across from the 45s was a 1, then across from the 90 is a square root of 2. In our 30, 60, 90 triangle, if across from the 30 is a 1, then across from the 90 is a 2. And across from the 60 is a square root of 3. So this is like our most simple basic form of the 45, 45, 90 and 30, 60, 90 triangle. It's 1, 1, root 2, and then 1, root 3, 2. So we're going to use this here, and we're going to do sine, cosine, and tangent of 45, 30, and 60-degree angles. So you can kind of see how if we use these basic things, we can figure out the sine, or we can figure out the cosine, or we can figure out the tangent of these different angles. All right, so we're going to start with the 30-degree values. We're going to calculate these all out. I really suggest maybe get a separate sheet of paper, something that you can place somewhere where it'll be really handy for you to kind of get at. If you're taking notes in a notebook, maybe start a new page, put some stars, highlight this. This is something fairly important. So let's go ahead and let's fill some of this in. So first of all, we're going to do sine of 30 degrees. So here's 30 degrees right here. Sine is your opposite over hypotenuse. So the sine of 30 degrees is 1/2. We'll then do cosine of 30 degrees. Cosine of 30 degrees is your adjacent over hypotenuse, so that's root 3 over 2. And then the tangent of 30 degrees. Tangent of 30 degrees is your opposite over your adjacent, so that's 1 over root 3, but we got to rationalize that to be root 3 over 3. Now our reciprocal trig functions, we're just going to flip each of these first ones that we found. Okay, so the reciprocal of 1/2 is 2. The reciprocal of root 3 over 2 is going to become 2 root 3 over 3. So we reciprocate and then rationalize. And the reciprocal of this last one, we're not going to reciprocate this. We're going to go back to this earlier version and make it just root 3. Now, you can memorize sine, cosine, and tangent of these values and then just flip them once you memorize them. But realistically, anytime you need these, you could just redraw a 30-degree triangle. And oftentimes I have people draw these at the top of all their quizzes and tests and worksheets and stuff throughout the year. Eventually, we'll do it so much that you'll sort of memorize certain ones, like sine of 30 is 1/2 or cosine of 30 is root 3 over 2. And I think you will memorize them eventually, but it doesn't hurt to draw that picture so that way you can refresh yourself on it. So as long as you can find the sine, cosine, and tangent of this picture, you can reciprocate and get all 6. Let's keep going. Let's do 60 now. So 60 is going to have very similar answers. We're just looking at it from a different angle now. So we'll start with 60 degrees. The sine is our opposite over hypotenuse. So that's root 3 over 2 this time. So it's what cosine was before. And then cosine is our adjacent over hypotenuse. So it's 1/2. So it's the reciprocal of what it was before. And if you think back to what we said with cofunctions, that actually makes a lot of sense. And then tangent of 60 is root 3 over 1, which is just root 3. So you'll see that a lot of stuff just kind of switched places. All right, so then we'll go ahead and we'll change, reciprocate this. So you get 2 over root 3. This time I'll show you the rationalizing, which becomes 2 root 3 over 3. Reciprocate 1/2, and whoops, I left this as a residual from before. This is 2 over 1, which equals 2. And then reciprocate, that's root 3 over 1, so 1 over root 3, which becomes root 3 over 3. So once again, eventually you'll memorize at least the sine, cosine, and tangent. So sine of 60 is root 3 over 2, cosine of 60 is 1/2, tangent of 60 is root 3. Or you can just redraw this picture and find the sine, the cosine, and the tangent of that 60-degree angle. Anytime you want the cosecant, secant, or cotangent, you just reciprocate the top 3. All right, last but not least is 45-degree angle, and it's a little bit different than the other ones. So given a 45-degree angle, we'll start with sine 1 over root 2. 1 over root 2, we got to rationalize that to become root 2 over 2. Hey, cosine, since the two legs are the same length, cosine is also 1 over root 2, which will rationalize to be root 2 over 2. And then tangent is 1 over 1. So the tangent of 45 degrees is 1 over 1. All right, for the reciprocals, we're just going to reciprocate them again. So usually we reciprocate the unrationalized version. So cosecant of 45 is going to become root 2. Secant of 45 is also root 2. And cotangent of 45 is 1, like tangent, because flipping 1 over 1 is still 1. All right, so once again, you can memorize them. You'll probably memorize the sine, cosine, and tangent eventually of a 45-degree angle. We'll use it so much. But if you don't memorize it, you can just draw a quick 45, go 1, 1, root 2, and then find these different trig values. So I wouldn't be surprised if at the top of your papers, I see a bunch of you with a little 30-degree triangle, a little 60-degree triangle, and a little 45-degree triangle drawn up there, so that way you can figure this stuff out on the fly. That wouldn't surprise me to see that on your guys' paper at all. All right, with that, that is all I have for you today. If you have any questions, please reach out. Otherwise, get started on the assignment, and we'll talk about this some more in our next live session. Until then, I hope you have a great day.